we're going to be talking about two kinds of interest, simple interest and compound interest. We'll start off by talking about simple interest. Capital earns simple interest if the interest is calculated only on the initial capital for the entire term of the investment or loan. Using simple interest, the principal plus interest, or accumulated capital, is calculated by the following equation. C to the n is equal to C0, or the initial capital, times bracket 1 plus n times I. So the accumulated capital is equal to the initial capital times 1 plus the term of the investment times the simple interest rate. This is known as compounding with simple interest. Simple interest means that you are not charged interest on interest. This becomes most relevant with longer-term loans or investments. Let's say you borrow $1,000 for 5 years. At the end of the 5 years, you're going to pay back $1,000 plus interest. If the interest rate is 1% per annum, in other words, per year, that means you're going to pay back an additional 1% of that $1,000, which is $10, for each year you borrowed the money. If the interest is simple interest, you'd pay 5 times $10 over the 5 years. If you're taking out a loan, accumulated capital is the total amount that you'll pay back to the entity that gave you the loan. If you're investing in an interest-bearing instrument like a bond or a guaranteed investment certificate, a GIC, then it's the total amount that will be paid back to you when the term of the investment has ended. We invest $1,000, which is C0. The simple interest rate is going to be 2%, which is I, and the investment will be for 6 years, which is our term N. So the accumulated capital, which Cn equals C0 times 1 plus n times I, that's our formula. Now we plug in those numbers. The initial value, C0, is 1,000. The interest rate is 2%, so that's 0.02. And the term is 6, so we replace the n with the 6. We multiply that out. The 6 times 0.02 gives us 0.12. We add the 1 and the 0.12 together to get 1.12, and then multiply that by 1,000, and that gives us 1,120. So in 6 years, the accumulated capital will be $1,120. So discounting with simple interest is the inverse of compounding. It's a method to find out how much the initial capital was if you're given the accumulated capital. An example of this would be you want to have $25,000 to buy a car in 5 years. You think that you can earn 3% interest on a GIC. How much would you have to invest now to reach your goal in 5 years? Of course, thankfully, there's a formula for that. C0 is equal to Cn times 1 plus n times I to the exponent negative 1. Remember, in exponents, when you've got a negative, that's the same as saying 1 over whatever you've got there. So C0 is also the same as saying Cn divided by 1 plus n times I. Returning to the saving for a car example, you want to save $25,000 to buy a car in 5 years. You think you can earn 3% interest on a GIC. How much would you have to invest now to reach your goal in 5 years? Put up our formula and our definitions and start filling in the blanks. We've got $25,000 times 1 plus n, which we said is 5, times 0.03, which is the interest rate, to the exponent negative 1. Multiply them out, divide 25,000 by 1.15, and we get 21,739.13. So we need to invest $21,739.13 now for 5 years at 3% in order to have $25,000 at the end. Now, sometimes other variables may be missing from what we're trying to figure out. These equations can be rearranged, so we're solving for a different variable. For example, you might want to know how many years, or what term, it will take for a specified investment to reach a specified value given an interest rate. We're going to reorganize the formula now to get n alone. So we're going to try to find the term of investment. We start with the original equation, then we multiply the initial capital times the 1 and times the n times I, then subtract the initial capital from both sides, then divide by the initial capital to remove it from here, and then finally we divide by I, and we end up with n equal to the accumulated capital minus the initial capital divided by the initial capital times the interest rate. Let's look at an example. How many years will it take a $5,000 investment to double at an interest rate of 7%? We start with the initial equation. Then we substitute in each of the values, the accumulated capital minus the initial capital divided by the initial capital times the interest rate. Subtracting two numbers at the top gives us 5,000. Divided by 5,000 times 7, we can cancel out the two 5,000s to have 1 divided by 0.07, which when we do the math gives us 14.28. Therefore, it takes 14.28 years to double. We can do the same process to reorganize the formula to get I alone. It's essentially the same process that we went through to get n alone because n and I were multiplied together. If we have a $6,000 investment and need to end up with $10,000 at the end of 10 years, what interest rate do we need to get? We'll start with the initial formula and then substitute in each of the variables. We've got the accumulated capital, the initial capital again, and the term of 10 years. When we do the subtraction, 10,000 minus 6,000 gives us 4,000. Multiply the 6,000 times 10, which gives us 4,000 divided by 60,000. We do the math, and we end up at 6.7%. Therefore, we need to get 6.7% interest rate to meet our investment objectives. In a simple interest scenario, you can find one missing value if you're given the other variables. To calculate the accumulated capital, we have the equation where the accumulated capital equals the initial capital times brackets 1 plus n times I, which is the term of investment times the simple interest rate. To calculate the initial capital, we have a choice of formulas, whichever one you're most comfortable with, where we've got the initial capital is going to be equal to the accumulated capital times bracket 1 plus the term of investment times the interest rate to an exponent of -1, which we recognize to be 1 over everything there. We can calculate the term as we just did by n equals accumulated capital minus the initial capital divided by the initial capital times the interest rate. Finally, we can calculate the interest rate through a very similar formula where we start with the accumulated capital minus the initial capital divided by the initial capital times the term of investment.